Good afternoon, everyone. I hope you can all hear me well. So my name is Mohammed Midani. I'm the managing partner of Intexiv, and I'm also an assistant professor of materials engineering at the German University in Cairo. I would like just to take a few minutes to introduce PalmFil development team. So Lobna is actually one of our young inventors. Yobna has been working during her master work on characterizing and optimizing PalmFil fiber, and currently she's working on her PhD also in making PalmFil fiber composites for the automotive industry. And we have another amazing master student. Her name is Yomna Sharif, working with us. And I would like to introduce Dr. Ahmed Hassanein. Dr. Ahmed is one of the partners, founding partners of Intexiv, and he is considered our industry expert. And he is an associate professor of textiles engineering at Alexandria University. And I would also like to introduce Dr. Tamer Hamouda. He is our technology management expert. Dr. Tamer is also one of the founding partners of Intexiv, and he is a senior researcher at the textile division, the National Research Center of Egypt. So our team has a combined experience of more than 50 years working on fiber science, textiles technology, as well as composites engineering. I actually, I met Ahmed and Tamer when the three of us were doing our PhD in fiber and polymer science at the College of Textiles, North Carolina State University. And when we returned back to Egypt, we decided to join forces and work together on rediscovering our local resources so that we can create an economical value out of them to support the sustainable development of our local communities and improve their livelihoods. And we started a technical consulting company called Intexiv, and PalmFil is one of our projects. And we have some other interesting projects in the development pipeline. And we've been honored during this project to work under the guidance and mentorship of the legendary Professor Hamid El-Mosli, who is considered the founding father of date palm byproducts development and research. And I'm really happy that he was able to join us today. Okay, so I think we have 39 participants, so we can start chatting a little bit. So we all know that the entire world is currently struggling with plastic pollution, okay? But plastic is not just like plastic bags and wrappers. They dominate our everyday textiles and fibers. Think of synthetic fibers like polyester and nylon, or in a bigger sense, like man-made fibers, including glass and carbon fibers. But honestly, we can't blame the industry because this is like a supply-demand issue. The population is growing in a fast manner. The living standard is improving, and the demand for more textile fibers have been increasing. And on the other hand, we are still relying on very few natural resources for obtaining our textile fibers. So simply the industry had to shift to man-made fibers to bridge this gap between the increasing demand for textile fibers and the limited supply of natural fibers. And in order to reverse this shift back to natural fibers, we have to explore more sources of natural fibers and increase the biodiversity of fiber crops. And the key word here is biodiversity. So you remember, the old saying, don't put all the eggs in one basket. So this is, typically what it means. But unfortunately, for centuries, we've been relying on very few crops for obtaining our textile fibers. But today, I mean, with PalmFil Fiber technology, it's opening the door for newcomers to join the natural fiber library, not just from the date palm byproducts, but also from the byproducts of other palm species, such as the oil palm, and even from other agriculture residues from other crops, so that, I mean, collectively, they can like reverse the shift back to natural fiber. Should we wait a little bit before starting the presentation? I think we have 40 participants. We're expecting something like about 100, but let's continue. I mean, so what actually is PalmFil fiber? So by definition, I mean, PalmFil is the world's first textile fibers and reinforcements extracted from the byproducts of pruning of date palms, such as the frond and fruit stalks. I know that the first thing that comes to our mind when we talk about date palm fiber is this beautiful like mesh that surrounds the trunk of the date palm. But I mean, it's a very hard fiber, similar to coconut. But we're more concerned or talking about like those date palm frond stalks. This is what we've been working on. And one of the the common questions that we've been getting, like, is it really the first textile fibers extracted from those frond stalks? I mean, honestly, there have been several previous attempts, but most of them were mostly focused on like crushing or grinding the frond stalks into like powder-like particles or very fine particles, or even shredding them into something like wood chips. Yes, I mean, those are good. They can be used like in making particle board or some sort of oriented strand board, but by no means these are considered textile fibers. Simply, they don't have like enough fiber length, flexibility, or even cellulose purity to be spun or woven or processed into any other textile form. So I would like to introduce, introducing the world's first textile fibers that are extracted from the byproducts or the frond and the fruit stalks of the date palm. And it's very similar, I mean, to other textile fibers. So this is flax, also known as linen, and it's even more similar to a wonderful like high performance vegetable fiber called sisal. It resembles it in appearance, performance, and even texture. And we've been able to like spin it, process it, and spin it into yarn, and I mean process it into other textile forms. Let me just go ahead and start sharing the screen. Lubna, can you see my screen now, Lubna?
Yes, I can see your screen. Yes.
Okay, thank you so much. Okay, so so far I've been talking about some of the plant-based fibers. They are also known as vegetable fibers. And those fibers are actually superior in properties. But unfortunately, many of them have been forgotten in the modern context. But nowadays, many of the industrial companies are pushing the limits and rediscovering those vegetable fibers in modern applications with very high added value. And this explains why the world consumption of vegetable fibers, excluding cotton, have been, I mean, growing in a very fast manner over the past 10 years. I mean, with a compound annual growth rate about 4.2% and reaching a market size of almost $4.7 billion in 2019. And you can see this exponential growth between 2017 and 2018. And I mean, we believe that if we can provide a new source of vegetable fibers, this exponential growth can continue. The major importer of those vegetable fibers is Asia Pacific, accounting for more than 50% of the world imports, followed by Europe, accounting for 25%. But what about date palm byproducts? So, I mean, date palm, it's the main element of flora in the Middle East and North Africa. And I mean, it has a very prestigious position in the hearts and minds of the people in this region. I mean, simply it's a symbol of our cultural heritage. Think of the flag of Saudi Arabia, or the largest man-made island that was built in Dubai. It had the shape of the date palm. So it's actually a symbol of our cultural heritage. And globally, there are more than 140 million date palms, mostly concentrated in the MENA region, and they are generating more than 4.8 million tons of byproducts of annual pruning. And those byproducts, I mean, in the past, they were considered an important indigenous material that were used in literally every aspect of living. So the frond stalks, they were used in making crates, furniture, and even fishing boats. The leaflets were used in making, like they were braided and made into like mats and baskets. Even the trunk at the end of the palm life, they were used in building and roofing. So, and entire villages, I mean, were specialized in making those products. And everyone in this village would be involved in this business. And at a certain point in time, this crate made of the palm frond was considered the state-of-the-art technology, and it has been the product of the technical heritage that has been passed down from one generation into another. But unfortunately, it seems that this is where the technology has stopped evolving. And with the widespread of plastics and other synthetic materials, they just took over this, they just took over this indigenous industry. So like the entire economies that were based on making those products, they just collapsed. So unfortunately, those byproducts turned from being a resource into a burden on the environment and on the palm growers themselves. I mean, at the end, they need to get rid of them. So what they do is just, they open field burn them. So they became one of the main causes of fire accidents and infestation by dangerous insects such as the red palm weevil. So we saw a very good opportunity here to use those large quantities of agricultural waste and convert them into 1.2 million tons natural textile fibers, and we call it PalmFil. And it's actually very versatile fiber, and it can be processed into many textile forms, including long fibers, chopped fibers, and spun yarn. And it can also be made into non-woven mats and woven fabrics. And it can even be like mixed with a binder and pressed into a strong and lightweight natural fiber composite. And those unique features and characteristics of PalmFil make it an excellent sustainable material base for a wide range of industries. So for example, in the automotive industry, like natural fibers are being used as a reinforcement for composite components, composite panels, like the internal door panels, the parcel shelves, like trunk liners, seat backs, and other like non-structural composite panels inside the vehicle. And this is a very, I mean, very exciting and market. It's a new market, but it's growing very fast. Simply, natural fibers, they provide what the automotive industry need. I mean, in terms of strength and in terms of lightweight, they are like 50% lighter than glass fiber. So it provides weight saving and consequently like fuel economy. And they also have some traditional applications like in like gypsum plaster reinforcement. You can imagine how much gypsum plaster we have in all the buildings. And also one of the well-established applications is in carpet backing. This is a huge market, and we've been getting several like collaboration requests from some of the world leaders in carpet backing, also in making insulation bats, thermal and sound insulation. And also we've been discussing with a French company specialized in insulation. They are very interested in PalmFil Fiber. And one of the traditional applications is in packaging, like in making burlap sacks and in making like Haitian fabrics, but also like making food and beverage containers, like those biodegradable food and beverage containers is becoming like an emerging application as a substitute to the single-use plastic like utensils. And we know that, for example, in Europe, next year, they will ban those single-use plastic cutlery. Another emerging application is in the non-wood paper. So it's simply like a paper that is obtained from sources that didn't require like cutting forest trees. And this is finding very good applications in making like banknotes, specialty papers, and other decorative and premium paper. And we've been also discussing with a French company, one of the largest French companies in paper making, about like collaborating in this. They already have like a specialized program for making like a non-wood paper. I mean, I think the technical term is botanical paper. And in addition to other applications like ropes and twines, and even they can be used as a reinforcement for composites used in making sporting goods such as surfboards, canoes, and yachts. And this is a beautiful, yacht that was made entirely from natural fiber composites by green boats. So PalmFil fibers, they have like a unique set of features and benefits. I mean, they are very sustainable. I mean, they are obtained from renewable bioresources. They do not cause deforestation. They are 100% biodegradable. They do not compete with food production. And on top of that, they are carbon dioxide neutral. I mean, think about like every palm has the ability to absorb more than 200 kilograms of carbon dioxide every year. And they're also abundant. I mean, as I said, I mean, there are like more than 140 million date palms with very high populations in countries like Saudi Arabia, like Egypt, the United Arab Emirates, Algeria, and the estimated fiber availability could reach up to 1.2 million tons per year. I mean, ranking third after cotton and jute. And yes, it is economical in manufacturing, and it has like a cost advantage because simply it's an agriculture byproduct. I mean, it's considered as an agriculture waste with a zero price in the field, and it doesn't require any extra investment in water, fertilizers, or pesticide, or even land. And it's a high performance fiber. I mean, its specific tensile strength is 5 times higher than structural steel, and it has even higher vibration damping and acoustical insulation than carbon and glass fibers. And it has also higher thermal insulation than carbon fibers. And in terms of lightweight, I mean, PalmFil is 50% lighter than glass fibers, and it's even lighter than some of the popular vegetable fibers. And it's safe for the working environment. It doesn't require any special personal protective equipment when handling. And the good thing is that it is highly compatible. It is highly compatible with existing like textile spinning and weaving technologies, and they can be easily blended with other natural fibers. So how is it made? This is one of the important questions. So actually, PalmFil is based on like a proprietary technology for extracting long, fine, and flexible textile fibers from the date palm fronds. So if we look closer at the base of the frond stalk, we will find that it is composed of like tubular, coarse tubular fiber. Think of it as like a pipeline that is intended to transport moisture and nutrient to like the different parts of the frond. And in the wall of this like tube, there are fine microfibrils. However, those fine fibrils and those tubular fibers are embedded inside the frond stalk and surrounded by a glue, a natural glue called lignin. So, and you can see some traces of this natural glue on top of the fiber. So our technology is based on like removing this natural glue, and meanwhile like eliminating this hollow cavity, this like hollow content at the center of the fiber by splitting this brittle and I mean inflexible fiber, splitting it into like longitudinal strands so that they become more flexible, and further fibrillating those into finer fibrils, but most importantly, without damaging or breaking those fibrils. And actually, PalmFil contributes to the circular bioeconomy. I mean, following a closed loop life cycle from cradle to cradle, from starting from the date palm plantation and ending back inside the soil of the date palm plantation. And this is just a comparison of the different properties, like the mechanical, the chemical, and the physical properties of date palm fibers. I will not go through them in details, but you can just look at them and you will find that their properties are very comparable to other high performance vegetable fibers. And we are very positive that further investment in this technology will help us in further enhancing the fiber properties and in refining those fibers. I mean, in other words, this is not the end, it's just the beginning. And we are very confident. We're starting with a very good starting base. But it has been a long 5 years of self-supported research. I mean, we've been relying completely on our personal funding in this project, driven by a strong belief about the impact of such innovation on the sustainable development of rural communities. So we came a long way. I mean, we came a long way across, like passing by the proof of concept and the prototype development. And we are currently in the pilot stage. So we are able now to like produce the fibers in small quantities, but we are seeking like a sponsorship to be able to scale up this technology into a further, like into a full industrial and commercial scale. And we also did several like industrial trials, like we did a semi-industrial extraction batches, and we did a spinning trial on an industrial spinning line, and it was in the Egyptian Industrial Center for Spinning. I'll just go through. And the good thing is that the fibers were very compatible with the existing spinning system. I mean, we didn't need to make any changes or make any special setup for the spinning. You can see it's running very good during the hackling, and even afterwards during the spreading. And you can see this beautiful spinning toe coming out from the spreader. And then going to the ring frame for spinning and for yarn making. And this was a very important milestone for us. You know, spinning is always one of the bottlenecks in the textile value chain or in the textile chain. So in other words, I mean, if you can't spin it, you can process it into any other form. And this is our outlook for the next steps in the development of PalmFil and our estimated timeline. So we divided them into two streams of development, like a technical development and a commercial development. So in terms of technical, we are planning to work on refining the technology as we start building our pilot unit. And we're hoping that after 9 months, we can start having our pilot production of this fiber. And in parallel, we want to work with industrial partners to start developing the end-use applications and markets. And afterwards, we start scaling up the technology into a full industrial scale. And in terms of the commercial development, we want to work on evaluating and developing the supply chain to ensure consistent and supply of the feedstock of those palm fronds. I mean, but the good thing is that traces of this supply chain still exist. I mean, in countries, for example, in Egypt, we still have markets for trading those front stalks for making crates. So the good thing is that the value chain still exists, or the supply chain still exists, but we need to further develop this supply chain. Also, we need to work on the ingredient branding of this fiber to ensure and maintain its visibility, as well as its value throughout the entire value chain. And finally, going through commercializing this technology. I mean, the entire plan from end to end is about 2 years. Strongly believe that there is a very promising future for PalmFil fiber as a novel class of natural fiber with an estimated market worth of about $2.5 billion annually. But we're looking for sponsors to help us in scaling up and commercializing PalmFil technology. We're seeking partners to collaborate with us on developing the end products. But we're open to work with all partners. We're willing to share and transfer the ownership of the know-how and the technology with our partners. But the important question is, what do you get in return for this? I would say that, for example, for industrial partners, there's a very good opportunity here in becoming greener industry. There's a very good opportunity here in having a new sustainable raw material and having access to new markets with unique competitive advantages, in addition to having raw material that is like it has sustainable supply, it has a cost advantage, and for developmental organizations. I mean, there's a very good opportunity here in building like a new industry, entire value chains within rural communities, within local communities. Like, I mean, we can generate thousands of decent jobs, combat poverty, improve the livelihoods of those people. I mean, and all of this based on their own local resources, the resources that they have very good technical heritage working with. وبالنسبة لمجتمعاتنا العربية، أنا يعني برضه حابب أقول إن في عندنا فرصة ذهبية هنا، فرصة ذهبية إن إحنا نصيغ ثورة صناعية جديدة، ثورة صناعية النسخة الخاصة بينا، مبنية على الموارد المتجددة بتاعتنا، واللي لينا فيها ميزة نسبية عالية جدا. ليه؟ لأن إحنا عندنا لسه ريف حي بيسكنوا أكتر من 50% من السكان، زي مثلا الحال في مصر. ولو قارنا مثلا بدول تانية زي أوروبا مثلا، هنلاقي إن الريف تعداد السكان فيه لا يتجاوز 5%. فإحنا في عندنا الميزة النسبية دي. الريف عندنا لسه حي، لسه عنده ذاكرة من التراث التقني اللي تساعده إن هو يستفيد ويستغل الموارد دي عشان يبني اقتصاد حيوي دائري وقوي. ف I hope، أتمنى إن احنا نقدر نستفيد من الفرصة دي. And I know that some of you might be like asking, like, man, why are you wasting your time with this? I mean, this is part of the past. But honestly, we strongly believe that this is the future. This is a renewable resource. I mean, a resource that has very high tolerance to harsh environmental conditions. I mean, it can't tolerate climate change. It can't tolerate desertification. It can't tolerate water scarcity. And probably it will be bare when the world runs out of like oil resources, when the world runs out of climate sensitive crops. So we strongly believe that this is the future. And I would like to conclude with a quote from our mentor, the legendary professor, Dr. Hamid al-Mosli. He would always say that renewable resources plus innovations in the presence of the appropriate conditions will always lead to sustainable development. And we have our own renewable resources, and we have our own innovations. And if we are serious about sustainable development, we must make those conditions appropriate. We must provide the appropriate conditions. We must invest in the applied research and the pilot research in this area. And with that, I would like to conclude, and I would like to thank you so much for your attention. And we would be happy to answer any of your questions. And sorry for taking that long. Thank you so much.
And, from this point, we thank you, Dr. Mohammed, for the great presentations, and we hope that everyone enjoyed the presentation. And if you have any question, please write it down in the chat bar, and we will be happy to answer the questions. And I guess we have a question here from John, that he is saying, how do you test for lignin content, and any international standards for the testing method? I think Lubna can answer this question. Okay, go ahead,
sure.
Lubna.
I can answer this question. We mainly used the TAPI standard to determine the chemical composition of the fibers. It depends on determining the weight percentages of cellulose, hemicellulose, and lignin. We followed specifically for the lignin TAPI test number T222OM-11. Thank you.
Okay, thanks you, Lubna. Okay, and can you take the other questions?
Yes, I'll take it from here. Thank you. I had some disconnecting problem. Okay, some questions are not shown here. However, I have a question from Mr. Ahmed Kamal. He say, how can we get yarn samples so we check the production feasibility?
So Ahmed, would you like to answer this question?
We have another question also before this from Mac Carpet. I think they asking, where are we now, Muhammad? They're asking for that.
Yes,
the plan.
So let me answer this question. I mean, like, where are we currently? As I explained, I mean, we are currently in the pilot stage. We're still making the fiber in small quantities. We don't have the capacity or the pilot unit to start making like larger batches of fibers so that we can have like a supply for the industry to start prototyping and developing the end use. And this is actually what we need right now. So yes, there is no commercial supply of the fiber, but we're hoping that once we start working in this, once we get the right investment, in 9-month period, we can start having like a supply from our pilot production. Okay, other questions, Lubna?
Yes, we have another question from Mr. Fouada. He's asking, did we put in our consideration the limitation of the raw material price to avoid the price rise up by farmers who just look for fast earning?
Yes, I like this question. So sorry guys, I'm really motivated about the Q&A. So thank you. This is a very important question actually. So let me tell you one thing. I mean, actually, we're in this to improve the livelihoods of those farmers, to provide an extra source of income for the palm growers and their families, to empower the women workers. So, I mean, we just don't want to take them at zero price as they are currently. We want to have like a decent price so that they can get an income out of it. And also we can have a cost advantage. And it is our role to utilize those fibers in applications with higher added value so that this added value can return back on the palm growers and all members in the value chain. So I hope this answers your question. But I mean, yes, I mean, there's no measure. I mean, you can't control like the price once there is a demand. But perhaps like the government's contribution by setting policies and some regulations when it comes to the utilization of those byproducts of agriculture, pruning, it can help in this matter.
A question from Mr. Muhammad Ahmadi. He is asking, have you tested the mechanical properties of the composite reinforced with PalmFil and compared it with other natural fiber composites?
Yeah, let me, Muhammad, I think maybe Muhammad didn't mention that we have published a paper in a very prestigious journal called Industrial Crops and Products. And Mr. Ahmad, I refer you to this paper. You will find all the details about the physical, mechanical, morphological properties of our PalmFil. Yes. And also it compared with most of the popular other natural fibers such as flax, hemp, jute, and sisal.
Yes, I think Dr. Ahmadi was asking about like testing the composites made of fibers. Yeah. I mean, we haven't tested the composites from these fibers yet. Yeah. We are currently actually working on this. We have prepared some of the samples, and I mean, we're still preparing the samples and making them ready. for testing. And those are samples that are mixed with polypropylene matrix, actually malleated polypropylene matrix to enhance the adhesion between the PalmFil fiber and the polypropylene matrix.
Okay. We have a question from Mr. Adham Sayad. He has two questions. The first question is, how did you extract the lignin? We extracted using a mechanical method. The second question is, did you have the chance to investigate the reliability of palm residues supply chain in Egypt in serving a large-scale industrial process?
Okay, so Ahmad, would you like to answer, or should I go for the question?
Yeah, actually, our extraction is based on chemical and mechanical. We combine both. We cannot say the details in detail now, but we using combined methods to extract the fiber with you know, to get the optimum properties and the most cellulosic content of the fiber. For the other question, I think Dr. Mohammed Medani mentioned that fortunately we have the supply chain, very old supply chain in Egypt, and it already existed according to the old, you know, there is already old handcraft was based on the residuals of palm tree. So the good thing about the logistics, because I know, and we would always discuss in this point that many people, when we go to recycling or agriculture waste, they get afraid and scared about the logistics and the supply chain. But fortunately for the date palm, we already have these supply chains from a long time ago. The only thing that we need to refresh it. And I think our product, PalmFil, will able to revive the supply chain, this old supply chain which is already existed, and some of the Egyptians knows that we already have a market for the palm frond or midrib or greed, so greed in Arabic.
Okay. We have another question from Mac Carpets. They are asking, how can we as textile manufacturers participate to help you get a commercial product?
So let me just quickly answer this question. I mean, this is a very good question, and we're glad that the industry is really excited about this. I mean, we've been getting several collaboration requests from many of the world big companies, some of the third largest company in sportswear and footwear. They were very interested in this fiber, and they want to further work with it. Also from all industrial partners in Germany, in France, and in Egypt. As I mentioned, there are two classes of collaboration. I would say that the first category is sponsoring this project. I mean, we are looking for sponsors to scale up and further commercialize the technology. But on the other hand, we are also looking to work with partners to collaborate on developing the end use. So for example, working with companies in the floor covering, by developing the necessary carpet backing quality for their end use, by working with, for example, companies involved in non-woven, by providing the fiber properties that is suitable for carding and suitable for non-woven processing, and so on. So there are two classes, either sponsoring this research or collaborating on developing the end products.
Okay. We have another question from Mr. Fahad Mansour. He's asking, have you transferred this innovation idea into a real commercial product?
Tamir, would you like to answer this question?
Yeah, sure, Mohammed. Yeah, about the transferring this innovations idea, we still working in different end use products. We have not yet transferred these ideas to a real commercial product, but we're working with several end users that we got a request from them to try to kind of adjust our palm fibers to satisfy their products, and we still in this process.
Okay.
I'm not sure if Muhammad, do you want to add something?
Yeah, I mean, our main goal, I mean, we are technology developers. So our main goal is to develop the fiber extraction technology so that it can be compatible with different end use. And once we have this raw material available, I mean, it is the role of our industrial partners to start developing their end products. I mean, in partnership with us, definitely.
Okay. Mr. Hassan al-Dusui is asking, is there any funding call between Egypt and UK? Then we can consider or any other alternative routes to collaborate.
Yeah, let me ask this question as I'm surviving, struggling now with the UK Newton Fund with Northern Beria. I don't, I don't, recommend this kind of funds, especially from the Egyptian side. The money is always get late, and the problem with the intellectual property rights. This kind of governmental associations or governmental organizations, they give you the fund and they take almost all the intellectual property. That's why we avoiding this kind of organizational or governmental organization.
Okay. Another question is asking, are your products TCF or ECF? And I guess this is related to the bleaching process of the fibers we used. Does it contain chlorine or it's free of chlorine?
Okay. Yes. So let me answer this question. Okay. So I mean, like the extraction process of our fibers, it doesn't involve any chlorine or any bleaching. So yes, it's chlorine free. But even if we wanted to bleach them, we would go to the hydrogen peroxide, which is more sustainable and environmental friendly bleaching process. So yes, I mean, it doesn't contain any chlorine.
Yes, so it's totally free of chlorine. This
Yes,
makes it TCF.
I would like to add that PalmFil Fiber is a native cellulose fiber. I mean, it's a true cellulose fibers like sisal and flax. It's not regenerated like other regenerated cellulose like viscose and lyocell. So this even makes it more sustainable.
Okay. Another question by Oriental Weavers. Can you develop fiber to be spun by semi-worsted system?
Ahmed, would you like to answer this question?
Yeah, actually, we have done our trial in the flax spinning system, which is very close to the semi-worsted systems. But we didn't, to be honest, we didn't try in a semi-worsted, but our trial were on the flax dry systems, which is very close to the semi-worsted.
Yes, I would also add one thing. I mean, so because the semi-worsted spinning, I mean, I think the length limitation is up to, I would say like 50 or 80
50, 60 millimeter, yeah.
Yes, but I mean, it was for us, it was the biggest challenge to extract those long fibers up to 1 meter or even longer. But I mean, it becomes much easier for us to extract shorter fibers and even like chop them into like the desired length that is compatible with like whether the semi-worsted or even woolen system. But this is something that we need to start working on.
Okay, we have another question by Mr. Ahmed Kamal. He's asking, what is the price per ton?
So, Ahmed, do you answer?
Yeah. We roughly calculate our depending on our cost of manufacturing and raw material. Unfortunately, we find that we will not exceed from $1 to $1.5 per kilogram, which is considered one of the cheapest natural fiber like jute. So it's gonna be around $1 to $1.5 per kilogram.
Yes, and I would like to add one thing. So, as I said, I mean, the technology is still evolving, and based on like the sponsor who will direct this further commercialization, we can tune this technology so that it can be like tailored for small scale companies. I mean, so that it can fit small production units, like distributed among different villages and different points, or it could be like a large scale, fully automated central like extraction unit with high like mass production and high economy of scale. So I mean, the technology even is versatile, and it can be tuned for both like a semi-automated processing with small scale companies, or fully automated large scale processing.
Okay. We have a question from Mr. Adel. He is asking, is there any feasibility study done? And what about the technology? It's considered an expensive one.
Tamer, would you like to answer this question?
Yeah, sure, Muhammad. This is one of the good things that related to the extraction. It's not that expensive. Also, we can rely on existing technology for some end products like fibers or the spinning mills. The main concept that we are working on is the extraction process. And this is the main part in the development of the fibers, is the extractions. And I may also answer another question that's talking about the extraction using chemicals or some solvent that is harmful for the environment. And this is one of the big concern about our project in PalmFil, that we are away from the solvent that is harmful. We are developing some techniques that depend on using a very safe chemicals, or even using just some technology that is not causing any harmful to the environment.
I mean, we've been getting, I mean, we're currently like working also on like an alternative extraction technique that is based on biological separation or extraction of those fibers. And we've been getting very good results. I mean, and also we're trying to go fully mechanical extraction. But again, I mean, we can't say that we reached the end. As I said, I mean, we are in the beginning, and like the possibilities are still ahead. I mean, I would say some of those vegetable fibers, I mean, they took centuries and thousands of years to evolve into this economical technology that we see today. I mean, flax has been used since ancient Egyptian, so we need some time to perfect this technology to be in a competitive technology that compete with other textile fibers. And one of the things that I would always like to say is that PalmFil, it's not intended to compete with the natural fibers, but it's actually intended to complement the offering of natural fibers. As I said, I mean, so that collectively having like a larger and more sustainable supply of natural fibers to support the industry to shift back to using natural fibers. I hope we didn't take you to so many different parts, but I hope we answered your question.
Yes, it's past 1 p.m.
Yes.
Please, if you have any further questions or you need to discuss anything privately with the team, send them at info@palmfil.com. I will type the email here. Thank you for sending these questions and for participating in this webinar. I will hand it over to Dr. Mohammed to give the final conclusion.
Thank you so much, Lobna, and thank you so much, everyone who were able to join us today. I know it's a vacation season, but taking the time to join us, this is very, very important to us. We are, as I said, we are very confident that this is a new fiber that will have a strong impact, not just on the, like, as I said, the sustainable development of the local communities, but also it is capable of revolutionizing the industry, of making the industry greener. And this is actually what we're aiming for in partnership and sponsorship with all our industrial partners and all our developmental organizations and government associations. Please, I mean, as Lobna mentioned, if you have any questions, reach out to us. We want to further discuss this with you. Thank you so much again, and enjoy the rest of your day. I would just go ahead and end the meeting, and we will be able to share with you the recording of the meeting, so that if you just joined in sometime later, you can always watch it, the full video. Thank you so much, and bye-bye.